Okay, looking into determining Laplace transforms by integration. And again, we're just going to look momentarily into integration, and we're going to make the process a bit smoother once we get into the tables. But for right now, okay, we have for Laplace transforms, okay, we have the improper integral as t goes from 0 to infinity, and we're looking at integrating the function f of t by e raised to the negative st dt. And let's say that if we have our function to be e raised to the 3t plus 1, well, for our Laplace transform, so we have f of s is equal to the Laplace transform of f of t, where again we have f of t, we have it e raised to the 3t plus 1 power. And if we substitute, okay, so we have in the improper integral, we have e to the 3t plus 1 times e to the negative st dt. And if we look at multiplying, so I have e to the 3t minus st plus 1. And what we can do to make things a little bit simpler, okay, is that for e to the first, that is going to be e. And I can just move this to the outside since the natural logarithmic base e is a constant. And so we have times the integral as t goes from 0 to infinity, and we have of e to the 3t minus st. And just looking at what we have now, okay, and just putting what we have in the variable exponent in factored form. So we have e times the integral as t goes from 0 to infinity. And we'll say we have e, and I'm going to do here factor out negative t. And we'll say we have e to the negative t times the quantity. And I'm just going to say, instead of negative 3 plus s, I'm going to say s minus 3 dt. And looking at what we have for the general integral, what we have for e to the 3t minus st. So if we step aside at the moment, okay, so we have with the integral, so we have of e to the negative t times the quantity of s minus 3 dt. Okay, and here we can apply u substitution. So say we have u is equal to negative t times the quantity of s minus 3, and taking the differential over both sides. So we have du is going to be equal to the negative of the quantity of s minus 3 dt, and expressing dt in terms of du. Okay, so we have dt is going to be the negative of s minus 3, or we can just go ahead and undo the negative. So we'll just go ahead and say we have du over 3 minus s is equal to dt, and putting what we have in terms of substitution. Okay, so we have for dt, I'm just going to put the reciprocal of 3 minus s out to the front. And we have times the integral. Okay, here we have of e to the u, and just have du inside the integral symbol. And for what we have in the follow-through, okay, so you have right now we have 1 over 3 minus s, antiderivative of e to the u du, okay, that's going to be e to the u plus c. So we have collectively, we have e to the u all over 3 minus s, followed by the constant. And we have, in terms of the back substitution, we're going to have e to the negative t times the quantity of s minus 3 all over 3 minus s followed by the constant. Okay. And reverting back to what we have in the original integral. Okay, so right now, if I put what I have here in terms of limits, so we'll say we have the limit as b goes to infinity. We have e times the integral. Now I can actually move that e out to the front. So we say we have e going from 0 to b of e to the negative t times the quantity of s minus 3 dt. And I'll go ahead and just move the coefficient e out to the front. So we have e times the limit as b goes to infinity. And for what we have, again, for the antiderivative, I'm putting this inside. So the antiderivative, okay, again, as t goes from 0 to b, with b approaching infinity. Okay, so you have e times the limit as b goes to infinity. And we have, upon substituting, okay, so we have with the upper limit at b, so you have e to the negative b times the quantity of s minus 3 all over 3 minus s, and subtracting what we have in the lower limit. Okay, so we have minus, okay, what's going to be e to the 0, which in this case is going to be 1 over 3 minus s. And just looking at what we have in the layout. So I'm going to copy this step and just working with our concept of infinity. And as b tends to infinity, well, if you notice, we have e to the negative b. And in this case, you have the negative of infinity, and we have for e to the negative infinity. Okay, that is essentially like the reciprocal of infinity, and that is going to tend to 0. So we can say that this term approaches 0, and we have minus 1 over 3 minus s. And so we're going to have e times negative 1 over 3 minus s. And to clean this up, okay, so if I take the opposite sign, in this case going from a negative to a positive, we'll have 1 over s minus 3 and multiplied by e. So we're going to have, for the Laplace transform of this problem, okay, this is going to end up as e all over s minus 3.